try to discover a little something to make me sweeter. Oh baby, refrain from breaking my heart.
2.2 is on factorial notation and permutations, and we're going to do this over 2 days. And the first day, today, we're going to do factorial notation, and the second day we'll do permutations. Okay, so let me remind you of something we did last day. Let me write a word here. Great word, pickle. Okay, if I wanted to know how many ways I could take those letters, the P, the I, the C, the K, the L, E, and rearrange them, and how many different words I could make, even if they're not real words, but how many different arrangements I could make of these letters. So I have 6 spots, 1, 2, 3, 4, 5, 6. We did this the last few days. So how many letters do I have to choose from to put in the first spot? 6, 1, 2, 3, 4. There's 6 letters that could go in the first spot. But now that I've used one, how many letters go in the second spot? Or how many letters could go in the second spot? There's only 5 left for there. Now I've used 2. How many left here? 4. How many left here? 3. How many left here? 2. How many left for here? 1. And what do I do with all those in order to figure out how many arrangements there are? I multiply them. 6 times 5 times 4 times 3 times 2 times 1 will give you your answer. I'm not so much interested in the answer here. What I'm interested in is this pattern of multiplying successive lower and lower and lower numbers. This happens a lot in permutations, in combinations, and so what we have to help us with that is something called factorial notation. So factorial notation is the product of consecutive natural numbers in descending order to the number 1. So there's a lot of words in there. Let's see if we can figure out what all this means. The product, that means multiply, of, let's start with this, natural. What are natural numbers? Natural numbers start with 1, and then go 2, 3, 4, 5, right? Dot, dot, dot. Consecutive. Well, consecutive means in a row, one right after the other. 2 and 3 are consecutive. 62 and 63 are consecutive. In descending order, so actually this order is wrong because we want to be going down to the number 1. So it's the product of consecutive natural numbers that are going down until 1. And that's exactly what we have here. We have all natural numbers. They go down until the number 1. And we're multiplying them. There's the product in descending order. 6, 5, 4, 3, 2, 1. Okay, that's factorial notation. And the way you use factorial notation, you use this exclamation mark. So what this means is 4 exclamation mark. That does not mean 4. Right? It doesn't mean excited for. What this means is start at 4, and then you're going to get the product of consecutive natural numbers in descending order. So we're going to go down until we hit 1. 4 times 3 times 2 times 1. That's what that means. Can you hear the annoying car going by? Man, that's loud. So 4 times 3 times 2 times 1 equals 24. 3 factorial. 3 factorial means 3 times 2 times 1. Just keep descending those numbers. That equals 6. 2 factorial equals 2 times 1. 1 factorial equals 1. And then you're left with 0 factorial, and probably you're already filling it in, aren't you? Are you filling it in? You're putting a 0. I'm afraid that's wrong. It's not 0. How come? Well, we can use patterns here to help us out. What do you have to do to go from 24 to 6? You could divide by 4. That makes sense because you no longer have the, right? The only thing that's different between this one and this one is this one's 4 times too big because you multiplied by 4. So you divide by 4. What do you do to go from this one to this one? Well, this one is 3 times too big. You divide by 3 and you get 2. What do you do to go from this one to this one? You have to divide by 2. So if you look at the pattern, divide by 4, divide by 3, divide by 2, what are you going to do here? You're going to divide by 1. 1 divided by 1 is 1. Now, that's not intuitive, but it's the fact. It has to, in order to maintain the pattern, this is the answer to this. So you might need to put that in your memory banks or something, that 0 factorial equals 1. Also, another thing I want to show you, let's go back to this 4 factorial here. I've written it that 4 factorial equals 4 times 3 times 2 times 1. But do you see that 4 factorial, so I'll write it again, 4 times 3 times 2 times 1. I could also write 4 factorial is 4 times, what could I put here to just be finished with the whole thing? Instead of putting 3 times 2 times 1, I could put 3 factorial. Isn't that the same thing? Yeah, 3 times 2 times 1 is the same as 3 factorial. Or I could put 4 times 3 times 2 factorial. Or this doesn't make really any sense, but you could put 4 times 3 times 2 times 1 factorial, but 1 factorial is just 1, it's not really that bad. But this is important, this fact that you can write this in multiple different ways, because sometimes writing it in one of these different ways is actually going to be the easiest way to answer the question, and you'll see that once we get down below. Okay, one more thing. Here's how we represent factorial notation mathematically. So we have n factorial. N can be any number. Well, actually not any number. We'll talk about that in a second. N factorial equals n. So for example, it's 4 factorial, you'll start with 4. If it was 2 factorial, you'll start with 2. If it's n factorial, you'll start with n. Times. Now we need the next number down, right? In descending order, the next consecutive number. So 3 is 1 less than 4. 1 is 1 less than 2. What's 1 less than n? N minus 1. Then you multiply by the next one, which is n minus 2, and then the next one, which is n minus 3. And we keep going, times n minus 4, n minus 5, as long as you, and you keep doing this until you end up with 3 times 2 times 1. Now, of course, if the n here was just 3 factorial, you just go here, 3 times 2 times 1. Okay, anyway, that's how you represent this. And as I was just alluding to, n can't be any number. N has to be a whole number. So remember, whole numbers start at 0. So it could be 0 factorial. What's that equal? 0 factorial is 1. We already did that down here. Hopefully remember that. It could be 1, 2, 3, 4, 5. But you can't have any fractions. You can't have any decimals here. And you can't have any negative numbers. Right? It doesn't make sense to say 3.2 factorial. Because what would you do? 3.2 times 2.2? No. It just doesn't work out. It doesn't make sense to have 1/5 factorial. I mean, what do you... And it might seem like it's okay to have -2 factorial, but what's the problem with that? Well, then you'd go -2 times, the next one down is -3 times, the next one down is -4. What's the problem? You're never going to stop. You're never going to hit +1. You're going to go forever. So none of these work. Okay? Has to be a whole number for n. Alright, let's answer some questions. So we want to do 7 factorial divided by 4 factorial. Now, one way you could do this is you could do 7 times 6 times 5 times 4 times 3 times 2 times 1 and actually multiply all that out. And you could do 4 times 3 times 2 times 1 and multiply all that out and then divide and get the answer. But what you need to recognize here is that on the top you have 4, 3, 2, 1, and on the bottom you have 4, 3, 2, 1. And since you're multiplying and multiplying, you can cancel them all out. So all you're left with is 7 times 6 times 5. Another way you could have done that, by the way, and this is what I was kind of, the reason I showed you this bit up here, is you could write this as this 7 factorial. I'm going to write as 7 times 6 times 5 times, now what might be smart to put right here? Just put 4 factorial. Rather than writing 4 times 3 times 2 times 1, just put 4 factorial. Why? Because on the bottom you have 4 factorial. 4 factorial and 4 factorial, those cross out. So all you're left with is 7 times 6 times 5, which we already said over here as well. 7 times, well, let's do it this way. 6 times 5 is 30, and 7 times 30 is 210. When you multiply, you can do it any order you want. I think that's the easiest way. Okay, 9 factorial times 3 factorial, all divided by 12 factorial. Let's start on the bottom. Why don't we go 12 times 11, how far do you want to go with this? Times 10 times 9 factorial. Why stop there? Because on the top you have 9 factorial, and we still have a 3 factorial. So this 9 factorial and this 9 factorial cross out. And in fact, maybe what we should have done with the 3 factorial is we'll actually multiply that out. We'll actually write that that is 3 times 2 times 1. Well, the 1 doesn't do anything here. Anything else you can do? Yeah, you can do some more simplifying. Like you could right now multiply and then simplify your fraction after. So what the heck, we'll show you that. 3 times 2 times 1 is 6. 12 times 11 is 132 times 10 is 1,320. And now I'm left with this awkward fraction. 6, I think you can divide them both by 6. 6 goes into 13 twice with 1 left over, so it's 6 into 12 is 2, and you get 1 over 220. But the other way you could do this is you could say, okay, I don't care about the 1, that does nothing. 3 times 2 is 6. Okay, so that's 6. And on the bottom here I have a 12. So if I divide top and bottom by 6, these are gone. And if I divide this by 6, I'm left with a 2 here. Now there has to be something left on top. I don't see anything. Everything's crossed out. If everything gets crossed out, it ends up being a 1. And on the bottom I have 2 times 11 times 10. Well, 2 times 11 is 22, times 10 is 220. So that's a nice way to do it too. Alright, pretty similar to this one. 10 factorial, how do you think we want to write that? Well, I see a 9 factorial down here, so why don't we just go 10 times 9 factorial? On the bottom we have that 9 factorial. Now, 5 factorial and 3 factorial, which one should I write out a little bit? The bigger one's the one you want to write out a little bit. I want to write 5 times 4 times 3 factorial. Why stop there? Because you have 3 factorial on the top. So we got a few things that'll cross out. 3 factorial and 3 factorial, 9 factorial and 9 factorial. Again, at this point you can either go 10 over 20, which is 1/2, or you could have gone, hey, 10 and 5, I could divide those both by 5. So if I divide this by 5, I get 2. If I divide this by 5, I get 1. And you can even go a step further than that. 2 and 4 you're left with. Divide this by 2, you get 1. Divide this by 4, you get 2. 1 over 2. You know, do it whatever way you want, but personally I like crossing out as much stuff as possible. Ninja slicing, as my grade 8s call it. Okay, so now we're doing the same sort of thing, but we don't just have numbers, we have these expressions like n plus 2 or n minus 1. So remember, we want to start with the one that's the biggest. So what's the biggest term here? N plus 2 is the biggest. So I would put n plus 2, then I'd multiply by 1 less than n plus 2. What's 1 less than n plus 2? N plus 1. What's 1 less than n plus 1? Just n. Should I put n factorial? No, because I don't have an n factorial. I just have an n, so that's good so far. What's 1 less than what's 1 less than just n? N minus 1. Oh, and look, we have n minus 1 factorial, so this is good. We'll stop here. We won't go n minus 2, n minus 3, n minus 4. Now we'll put the factorial sign. Because then on the bottom we have n times n minus 1 factorial, and so the n's cancel, the n minus 1 factorial cancels. I'm left with n plus 2 times n plus 1. And I think in your book they keep the answers just like that, and that's fine with me. You could, if you wanted to, do your mountains and your valleys and see what you get there. N times n is n squared, n times 1 is n, 2 times n is 2n, 2 times 1 is 2, and then you could combine these two middle terms. So you get n squared, n plus 2n. Well, that's like 1n plus 2n, which is 3n plus 2. And that's a good answer too. So it doesn't matter if you give this answer or if you give the answer up here. It's so messy now. Next one, same sort of thing. On the bottom it's a bit strange. You have n factorial squared. What might be a simpler way of writing that? Think, what does 5 squared mean? 5 times 5. What does m squared mean? M times m. So what does n factorial squared mean? It means n factorial times n factorial. So you have these two terms up here. You probably want to get them both down to so that they have an n factorial in it. So let's start with this one. N plus 2 factorial. I could write that as n plus 2 times what's 1 less than n plus 2? N plus 1 times what's 1 less than n plus 1? N. Perfect. Now I can put my n factorial. I can stop right there. Don't go n minus 1, n minus 2, n minus 2, because we're going to be able to cancel here. Okay, the next one is n plus 1 factorial. So I'll write the n plus 1, and 1 less than that is n. Perfect again. N factorial. Great. So now I can cross off the n factorial and the n factorial, the n factorial and the n factorial here. And what I'm left with is n plus 2 times n plus 1 times another n plus 1. Or you could make it n plus 2 times n plus 1 squared. Or the other thing to do is you could expand this all out, but I don't want to do that, and your book's not going to do that either. This is a good answer. Great. Now we're going to solve some equations with factorial notation in them. I really like these. I think it's kind of enjoyable. Alright, so let's start here on the left hand side. We're going to do exactly the same thing we were already doing. What's bigger, n or n minus 2? N. So that's the one we're going to write out a little bit. We're going to write n, and then what's 1 less than that? N minus 1. Better keep going. What's 1 less than that? N minus 2. Perfect. So we got n minus 2 factorial. And it's all over n minus 2 factorial, and it equals 42. Now, this is great because this cancels. So what I'm left with is n times n minus 1 equals 42. And this becomes a question like last year. Now, I don't know if you remember this, but what you would want to do here is you'd want to expand this. You'd want to do mountains. So you'd get n squared minus n equals 42. This is a quadratic equation. What makes it quadratic? It's quadratic because it has degree 2. It has a variable, variable n in this case, with an exponent of 2 on it. And the way we solve quadratic equations is we make them equal to 0. So you want to move the 42 over. N squared minus n minus 42 equals 0. So we make it equal to 0. And then what I try to do is I try to factor. Now you can't always factor. If you can't factor, you'd use like the quadratic formula. X equals negative b plus or minus. You remember it, right, from last year? But you're not going to have to do that in this class, I don't think, like not in today's lesson. So we will factor here. This is simple trinomial. There's no number in front of this n squared. There's a 1, but there's no 5 or negative 3 or anything, so you can go straight to the 2 brackets. Remember how to factor? What must the first two things be in order to get the n squared? N and n. And what we're looking for is two numbers that multiply to 42 and subtract, because of that sign right there, to negative, or to 1. There's a 1 in front of there, right? Now, if you weren't in my class last year, you're new to our school, you're like, what is he talking about? That's not. In fact, what you're really looking for is two numbers that multiply to negative 42 and add to negative 1. But I find a lot of kids at our school aren't so good with their integers. So I teach it as two numbers that multiply to 42 and subtract to 1. Can you think of what the numbers are? It's 7 and 6. So the hint, a trick I told you, this is the only time I think in the whole high school math I give you tricks. The trick is to put the big number first, 7, the small number here. Then all you have to do is drag down that first sign. So you get a minus. A negative times a what equals that negative? A negative times a positive equals that negative. And it's still equal to 0. Great. Now what we can do is you can use the zero product property. And the zero product property says if you're multiplying two things together and it equals 0, and that's exactly what's happening here, we're multiplying one bracket times another bracket and getting 0, then either the first bracket equals 0, the second bracket equals 0, or they both equal 0. So what would make this first bracket equal 0? If n was 7. If n was 7, you'd have 7 take away 7, which is 0. Okay, now this one, what would make this bracket equal 0? You would have to put negative 6 in there. Negative 6 plus 6 equals 0. So these are your two answers. All finished, right? Not so fast. What's wrong with one of these answers? What's wrong is that this answer is negative. We reject this answer. No negatives when you have a factorial, right? Otherwise you'd be saying that negative 6 factorial on top. You can't do negative 6 factorial. That would mean negative 6 times negative 7 times negative 8 times negative. It would never end. So your only number, in fact, that works in this case is n equals 7. And if you wanted to, you could try it. You'd have 7 factorial over 7 minus 2 is 5 factorial. And if we were to quickly do that, you'd have 7 times 6 times 5 factorial over 5 factorial. The 5 factorials cancel. You get 7 times 6 is 42. Absolutely works. Okay. Last one. So again, we're going to start with the left-hand side here and do the same sort of thing. What's bigger, n plus 2 or n minus 1? N plus 2. So we'll go n plus 2. One lower than that is n plus 1. Better keep going. One lower than that is n. Better keep going. One lower than that is n minus 1. Yes, that's what we want. Now we put the factorial. All over n minus 1 factorial equals 24 times n plus 1. Wow, what a mess. Okay, these cancel, because you have one on top and one on the bottom. Do you see that the n plus 1 and n plus 1 on both sides? So if you divided both sides by n plus 1, I'm going to divide this side by n plus 1, I'm going to divide this side by n plus 1, then those would cancel too. If you have the same thing on both sides like that when you're multiplying, you can cancel. So you're left with n plus 2 times n equals 24. It's very similar to the question we did up above. You want to multiply this side. So distributive property or mountains or whatever. N times n is n squared. 2 times n is 2n. Equals 24. It's a quadratic equation, so you want it to be equal to 0. Move the 24 over. N squared plus 2n minus 24 equals 0. Again, it's simple trinomial. It's still going to equal 0. The first thing has to be n and n. You're looking for two numbers that multiply to 24 and subtract to 2. Multiply to 24, subtract to 2. 6 and 4. Big number in the first one, small number in the second one, drag down that plus sign. A positive times a what equals a negative. A positive times a negative equals a negative. Now we use the zero product property. What would make the first bracket equal 0 if n equals -6? What would make the second bracket equal 0 if n equals 4? You like both those answers? I don't. I'm going to reject this one because it's negative. So my only answer is n equals 4. Want to check it? 4 plus 2 is 6, so I have 6 factorial. 4 minus 1 is 3, so I have 3 factorial. Equals 24 times 4 plus 1 is 5. Okay, 6 factorial, I'll go 6 times 5 times 4 times 3 factorial over 3 factorial, so those cancel, equals 24 times 5 is 120. I sure hope 6 times 5 times 4 is 120. 6 times 5 is 30, times 4 is 120. It worked. We got the right answer. Okay, that is factorial notation. You want to definitely make sure you understand this because for the rest of the chapter you'll be using factorial notation a lot.
That you give me no, 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 so